Hello friends, today we are going to discuss a general formula, general method to find out particular integral. So for linear differential equation f of dy is equal to capital X, where x is function of x, the general formula is this. Why this formula it is being used? Normally we are having shortcut methods to find particular integral, like the function capital X is exponential, sin x, cos x, logarithmic function is there. So many functions there, and we use shortcut methods to work out e to the power x into v and so on. So there are certain shortcut methods that already we have seen, and if in this particular shortcut methods, if the function is capital X, if it is complicated, it is like logarithmic, or if it is sec or cosec, then it is rather complicated to use the shortcut method or method of variation of parameters. So in that case we use this formula to find out particular integral of the linear differential equation with constant coefficient. So this formula is particular integral 1 upon d minus a. D is the derivative operated on x. X is some function of x there. Then we take e to the power x, it is outside, integral e to the power minus x, and then this capital X multiplied together and integrated with respect to x. Similarly, if in place of minus a we are having plus a, then 1 upon d plus a capital X is e to the power minus x integral e to the power x, means here if it is minus, then outside minus, plus sign, here minus sign. If it is plus here, then outside minus sign, and here it is plus sign. So this formula is to be used directly to find out the particular integral. Now let us see one counter example on this. Solve the differential equation d square plus 3d plus 2 into y is equal to sine of, say, e raised to x. So if you observe sine of e raised to x, there is no any other method to find out the particular integral. So solution for this, to solve this differential equation, it is d stands for d by dx, d stands for d by dx. So I write down auxiliary equation for this. Auxiliary equation is d square plus 3d plus 2 is equal to 0. So we find out roots of this equation. We find out two numbers whose sum is 3 and multiplication is 2. So it is d plus 1 and d plus 2 is equal to 0. So d is equal to minus 1 and d is equal to minus 2. So if you observe these roots, minus 1, minus 2, roots are real and distinct. So the complementary function is equal to c1 e raised to m1x plus c2 e to the power m2x. This formula it is being used here for real and distinct roots. So this is taken as m1, this is taken as say m2. So the complementary function is c1 e raised to minus x plus c2 e to the power minus 2x. So this is complementary function. I call this as expression number 1. Now to find out particular integral, there are two parts of the solution there. So particular integral we find out by the general formula, because there is no any shortcut method for this capital X, sine of e raised to x. We have formula for sine, we have formula for e to the power x, but if it is combined sine of e raised to x, so either it is to be done by method of variation of parameters or the general method. So we go for the general method. Particular integral is this is equal to 1 upon f of d operated on capital X. So f of d, I take this as d square plus 3d plus 2. This is operated on capital X, means sine of e raised to x. So I factorize this 1 upon d plus 2, d plus 1, and this is to be operated on sine of e raised to x term by term. So what I do here, first I operate 1 upon say d plus 2 and 1 upon d plus 1. This is operated on sine of e raised to x. So I just operate, I use this formula here, this formula I am using. So the first formula or second formula, it does not. So a is equal to 1 here. So I get this as using this formula here, 1 upon d plus 2 inside the bracket e to the power minus x integral e to the power x sine of e to the power x into dx. So it is something like this you are getting. If you apply this formula here, a is equal to 1. So I put the value of a minus 1 here, 1 sine of e raised to x. Now I integrate this. This is equal to integration of this. To carry out this integration, e raised to x sine of e raised to x dx, I put the substitution e raised to x is equal to t. Therefore, e raised to x dx is equal to dt, because in the pair it occurs e raised to x dx. You can replace for that, it is dt over here. So it is 1 upon d plus 2 inside the bracket e raised to minus x integration. So I transform this integral in terms of t, and that would be something sine of t here, and e raised to x dx is replaced by dt over here. So this is equal to 1 upon d plus 2 e raised to minus x, and integration of sine t, as usual by the formula, it is cos t. So I simplify this further after replacing this t d plus 2 and this one e raised to minus x cos of e raised to x. So something like this. Now I will consider second time I will apply this general formula over here. This formula I am going to apply. Now here one can resolve this into partial fraction also, and separately into two terms, and then separately you can apply general formula and then add up together. That is also possible here, or directly one by one you can apply this thing. And the method I have just discussed over here, you can just go through that also. One and the same thing, result would be same. So what you are doing here, the next, this is equal to minus 1 upon d plus 2. It is taken over here, e raised to minus x cos of e raised to x. Now I will consider this as capital X or function of x and operate again minus. I use this formula, a is equal to 2 there, a is equal to 2. So e raised to minus 2x integral e raised to 2x, e raised to 2x, e raised to minus x. I just take cos of e raised to x dx. So I will consider this capital X here, this is capital X. So I simplify this further, e raised to minus 2x, e raised to x, cos of e raised to x into dx. Now again I am using the same substitution here, because e raised to x is equal to t if you are using, or u, put e raised to x is equal to u. So e raised to x dx is equal to du. So this would be something like this. It is minus e raised to minus 2 times x, and here e raised to x dx because t is already used. So cos t dt I am getting there with the minus sign. So I integrate this. So I am getting e raised to minus 2x integration of cos t. It is sin t naturally, integration of cos t. Now I replace for t, it is or t, not, it is u taken over here. So it is du. So it is e raised to minus 2x and sine of e raised to x. So this is your required particular integral. Then we write down the general solution for this equation, this linear differential equation. General solution is y is equal to, we add together complementary function and particular integral. So complementary function is c1 e raised to minus x plus c2 e raised to minus 2x, and particular integral is this thing, minus e raised to minus 2x sine of e raised to x. Sine of e raised to x. So this is your required solution of this differential equation. So this is the way you can apply the general formula to find out particular integral. As I said right now, that formula is applicable if all the shortcut methods in fact fails, or it is rather complicated to find out the particular integral. Now we go for the next second problem. D square plus 5d plus 6 into y, this is equal to e raised to minus 2 times x, e raised to minus 2 times x, sec square x into 1 plus 2 times tan x. Now if you observe this problem here, it is a tough job to find out particular integral by shortcut methods. So we just go with this auxiliary equation we find out, because this equation second order linear differential equation, auxiliary equation is d square plus 5d plus 6 is equal to 0. So what we do here, we find out roots, we search the number whose sum is plus and multiplication is 6. So the numbers are 2 and 3. So I will factorize this as d plus 2 and d plus 3, and naturally the roots would be d is equal to minus 2, d is equal to minus 3. So roots are real and distinct. So we use the first formula to find out complementary function. I will consider this as m1 and this as m2. So the complementary function would be of this particular form, c1 e raised to m1x for real and distinct roots, real and distinct. So we are having this format, this formula to find out complementary function. To write down complementary function, e raised to minus 2 times x plus c2 e raised to minus 3 times x. So this is complementary function. I call this as expression number 1. So this is first part of the solution of linear differential equation. Now second part of the solution, we go here, it is particular solution or particular integral, and for that we are having the formula. It is something like this, 1 upon f of d operated on capital X, because this equation is of this particular form here. This is equal to capital X. Capital X would be this thing here, capital X. So it is capital X. So I write down this as d square plus 5d plus 6, because f of d is this thing here, and this is operated on this whole expression, capital X e raised to minus 2x sec square x into 1 plus 2 times tan x. 1 plus 2 times tan x. So we just factorize this, 1 upon d plus 3 and d plus 2 or d plus 2 d plus 3 e raised to minus 2 times x sec square x into 1 plus 2 times tan x. It is something like this. You may be getting. So I just operate this thing on this directly. So it would be using the general formula d plus 3, and this would be e raised to minus 2x, because a is equal to 2 here. Using the general formula, it is 1 upon d minus a operating on x, d plus a, e raised to minus x, integral of e raised to x into capital X. I am using this formula here. So it would be something e raised to 2x into e raised to minus 2x into sec square x into 1 plus 2 times tan x, because here capital X would be this whole expression there, 1 plus 2 times tan x into dx. So this is your capital X, and this is to be integrated here. So I just join these two here. It is e raised to 0. You are getting 1 upon d plus 3 integration e raised to minus 2 times x, and here it is e raised to 0, means simply it is sec square x 1 plus 2 times tan x. So like this you are getting again. So if you see the integral, this is parallel integral. Now if you observe tan sec square, if it is x square 2x, then sine cos. So these are the pairs there of the integrations. So here derivative and the function tan x sec square x. If it is there, cot if it is there, minus cosec square. So I use the substitution. Tan x is equal to t. So therefore sec square x dx is equal to dt. So I use this substitution and get it transformed in terms of t e to the power minus 2x integration. Now if you observe sec square x dx, I can replace it is dt and 1 plus 2 times t into dt. So I integrate this. So I simplify this further. It would be 1 upon d plus 3 e raised to minus 2 times x integration of this, it is t plus 2 times t square divided by 2. So it is this 2 may be getting cancelled. I replace for this t to be t plus 3 e raised to minus 2x inside the bracket. So t would be tan x from here, and it is tan x plus tan square x. T square means tan square x. So as usual, I said earlier, you can just resolve this into partial fractions also, and into 2 terms, and then join those 2 terms together. That is also possible, or 1 by 1 also you can just work out. Now I will consider this as capital X now, and reapplying this formula, general formula again, by taking a is equal to 2 here in the general formula, 1 upon d plus a x e raised to minus x integral a to the power minus x dx. Now I just take over here this and see what is happening here of this 1 upon d plus 3. So it is using the general formula, this is equal to the power minus 3x integration e to the power 3x into capital X. Capital X would be something e to the power minus 2x, that I have bracketed here, tan x plus tan square x, and this is to be integrated with respect to x. So we simplify this. This is e raised to minus 3x. Now if I join together by laws of indices, it would be e to the power x here into tan x plus tan square x into dx. Now I integrate this. So I simplify this to make it in the convenient form. I replace this tan square by sec square x minus 1 e to the power x tan x and I replace this by sec square x minus 1 into dx. So again I just simplify this further. It would be something like this: e to the power x inside the bracket, it is tan x plus sec square x into dx, and this term with minus 1, it would be something e to the power x dx. So it is this. Now as usual, you know the formula for 12 standard. This is f and this is f dash. So e raised to x f plus f dash, it would be e to the power minus 3x, and this formula, integration of e to the power x into f plus f dash, if it is function of x with respect to x, then integration of this is e raised to x into f. So plus constant of integration naturally. So it is something, this you may be getting this as e raised to x into tan x, and integration of this using this formula, f is tan x minus e raised to x, integration is e raised to x. Now I take e raised to minus 6 outside. So if I take it outside and join with e raised to minus 3x by laws of indices, it would be something this. So this is tan x minus 1. So you are getting this as expression 2, that expression 1 and expression 2. So we add up together and get the final answer. As usual of linear differential equation, the final answer would be y is equal to complementary function plus particular integral. It is this. So this would be c1 e raised to minus 2x plus c2 e raised to minus 3x as this thing, and second is this e raised to plus e raised to minus 2x into tan x minus 1. So this is required solution of this differential equation. So select